Okay, today I'm going to be doing a little demo on the little wireless radio that we actually make and supply. Before I go into explanations, let me give you a little history about this little wireless radio. Okay, the first crystal radio was developed actually around between 1904 to 1906. And the strangest thing is, rather than having a single inventor, the device actually emerged from the discovery from the Indian gentleman by the name of Jagadish, okay, in 1804. And he was the very first one to use galena. That is a material actually that the crystal is called, it's called galena. And he used it to actually detect the radio waves. And of course, that is the crystal diode. But nonetheless, we'll come to it now. Okay. Then, of course, in March, I think it was 1906, a gentleman by the Henry patented the actual crystal detector, the actual process, tapatin. And then, of course, later on in 1906, a gentleman by the name of Greenleaf Pickard patented the silicon crystal detector. Using in his patent application, he basically used a very thin, very fine wire touching that galena crystal, creating the iconic. Basically, it's called, they used to call it, and he called it cat's whiskers, for the, in order to be able to convert the RF signal into the audio signal. And by doing that, he basically created a germanium diode, let's put it that way. Of course, a gentleman by the name of Pickard, Greenleaf Pickard, he is basically predominantly and widely considered to be the actual one that made a breakthrough, because he is the very first one that made battery-free crystal radio, which is become a widespread reality, and even today it's still used, except with a much more modern sort of crystal diodes, more sensitive and things like that. All right, so at least now we've done a bit of a theory on the history of this wireless radio. Now this particular sort of wireless radio, in today's terms, basically it's called the crystal radio. As I said, we don't call it any longer cat's whisker because the actual diode is condensed and miniaturized and professionally sort of encapsulated and very easy to apply and to solder and to manufacture and so on, and always consistent sort of results you obtain from the diodes. It's called the germanium diode. Now let me explain the operation of the actual this wireless crystal radio. Basically, this is the simplest form of the any radio, and consists out of basically three components, and that is coil, which you can slide on the ferrite. By sliding it, you actually change the inductance of the actual coil, okay, and the fixed value capacitor. Now, by changing the inductance, you basically shifting the resonant frequency of the actual sort of tune circuit. And then, of course, as I speak, I'm just going to sort of start connecting up. Okay, basically, in order to be able to use the crystal radio, you require very good earth. Okay, so I'm connecting it up, and you can actually see it over here. I connected it up. To my scope. I don't know if you can actually see it over there. I connected it up to the scope, which is grounded. Okay, So basically, you require a very good ground, and then of course I'm going to use specific length, okay, of the, this one is just 2 meters or so, with the crocodile clamp. Of course, it has to be specific in order to pick up maximum sort of signal. So let me just connect up the antenna, and I connect it up where it says antenna. Very simple. Now, basically, there is no power needed, or batteries, or any sort of power source for this radio. How does it operate? Very simple. Okay, with this antenna that I've got connected, which is like in my case right now, it's on the floor. It's about just over 2 meters, and then of course with a grounding. Now, not only grounding, it also acts as the other half of the antenna. It's called the counterpose, but it must be grounded, and very, very good ground. And between the ground and antenna creates, the antenna picks up with the grounding, picks up basically medium wave, because medium wave sort of waves in the air, and then wherever the coil and capacitor is resonant, and if it is resonant on the station that it's being transmitted, it will basically high sort of RF signal appear over here, because it will accept and generate the maximum, it will capture and only pass that signal and attenuate all others, type of thing. Okay, and then with the crystal diode, basically now we remove the RF component and we make it into the actual audio signal, where we now connect high input impedance headphones or a high input amplifiers. And for that purpose, I have designed a little tiny little amplifier which can operate between 4 to 12 volt DC. And of course, I'm going to use it over here to demonstrate. The power is already connected to it, except speaker disconnected. And I've got about 10 volt connected. So the amplifier is ready, and I'm going to connect it up. Now, audio output, I connect the ground negative of the amplifier. And then basically, audio outputs, I connect the input to the amplifier. It's called the hot, or some people they call it positive or whatever. And then of course over here now my speaker will get connected, and my speaker is basically quite a biggish one. You can actually see it. It's actually, let me just try to zoom out. Sorry, it's difficult to operate the camera and to, okay, now let me just do this. Okay, now basically you can actually see the speaker. Okay, so right now, okay, let me put, say, in the middle the actual coil. Okay, and I got a bit of a plastic card, so I can, once I obtain the signal, I want to lock in. So our antenna is connected, our ground is connected, and the signal is already present over here. Now you're going to wonder, what is this capacitor there for? Okay, this capacitor is loose. And it is there, sometimes it's a harsh frequencies and it's too crispy or whatever, and then just by joining it, just by joining the capacitor to the hot or the positive or of the detector diode, you actually try to filter that noise so it sounds a bit more pleasant to an ear. Okay, that's one way I'm going to display it. And then, as I said, unfortunately, because signal being very, very small in couple of millivolts, you cannot use ordinary amplifier. It has to be high input amplifier. In other words, you cannot use your ordinary hi-fi auxiliary input or a tape deck or a CD input, because they require minimum 700 to 1000 millivolt sort of input signal. where this signal over here appearing coming from captured with the coil and tune circuit capacitor and a coil and the antenna and a ground only delivers like a couple of millivolts. So obviously you need a high amplification. Nonetheless, you can use high impedance headphones, but they're not very easily obtainable and they're quite pricey, expensive, if you're lucky to find them. But nonetheless, yet they are still around, but not easy to get. Nonetheless, here is the speaker that we're going to play it through. So without any further ado, I got everything connected, and the moment I connected now, I should be able to hear the sound. I'm going to keep on connecting and disconnecting this amplifier, and I'll use that by disconnecting the speaker. You can straight away hear the sound. Okay. Watch now. Watch now when I go. That's where I pick up basically the highest sort of signal coming out of the tune circuit, gets rectified into the audio signal, converted to audio signal into the amplifier. Now, if it's too loud, of course, I didn't put a potentiometer here on the input of my amp, but I'll use my decade counter and I'll try to let me just connect it up over here so you can make it pleasant to the actual ear. Okay. Now, let's connect the speaker again.
And that is Dr. Tumi this afternoon.
Now, watch now when I change.
And this is how we came out from our talk with Ubabu Nkosi. He's been with us ever since 1981. Can you believe it? Do join the family.
So basically,
a part of our faith generation. Help us continue to building stronger families for tomorrow. Your support to...
Okay, I'm just disconnecting the speaker so I can further explain. Okay, so I basically demonstrated goes into a tiny amplifier. I use the basically resistor across it, across the actual audio output as a potentiometer, and in order to sort of get the most pleasant sound and the best quality sound from this simple sort of wireless receiver. Now, this capacitor, as I explained, watch now what happens with the capacitor. It becomes, but eliminates a bit of a harsh sound that makes it a bit more bassy. Of course, it's open. You can add different value capacitors here and play around to get actually the most pleasant sound, for your sort of liking. Let's put it that way. Let me just put it. Okay. Watch now when I connect up. Okay.
In Cape Town, as 13 people are
listen
killed
to it
in
now.
a spate of shootings. I am Sibongile Mufuke with your 2 o'clock news bulletin.
Can you hear it? Okay.
National Treasury has ended its temporary fuel levy relief,
Okay.
removing a measure that had helped cushion motorists.
Okay, now you can definitely hear the difference in sound quality just by connecting a simple cap which acts as a filter. Okay, now I'm going to go one more step. Okay, now of course you cannot use ordinary amplifier, tape deck input, CD input, or auxiliary. Simple reason, because they are not a high input. They require, as I said, 1000 millivolts, where this is much too small. But most of the amplifiers, they do have a gram input, which is not ideal. The ideal would be a guitar input, any guitar amplifier, due to the high impedance of the guitar coils, electric guitar coils. They have got, by nature and design, a very high input impedance. And that's what actually would be ideal for this particular radio. But nonetheless, we're going to use and I'm going to use about the 8-inch speaker, which is under the bench. But you'll hear it now. Okay, right now I'm connecting basically the amplifier. I'm just going to disconnect the cap. Okay, and now listen when I put a bit of a volume. Okay.
And answer questions. How did you come into this country with this dollars? How did you come into this country? He's put the name of our president in jeopardy, saying that he came with money without declaring it. Have we fallen so much apart that we can do what they like?
Cape Town police are investigating a wave of shootings over the weekend that left at least 13 people.
Watch when I slide it.
Spokesperson Andrew Trout says 6 men were killed in Makaza and Edrovini, including 3 victims found in an...
Now it's slightly off the station. Now I'm gonna tune.
This morning, motives remain under investigations, and spokesperson Nobelo Botela also confirmed 7 more killings in Kaya. Multiple shooting scenes and no arrest.
Okay, you can hear it actually through the hi-fi. As I said, on the amplifier, especially if you got the equalizer, you can equalize the bass and treble and so on. But I'm just demonstrating it that yes, it can be done even through the household amplifier. Let me disconnect and go back to the speaker one more time, and then basically we're done with the demonstration of my little crystal radio. Cat's Whiskers, known in past and right now it's known as crystal radio and still widely used. Okay, let's try to connect up the speaker.
As residents, businesses and investors live in fear, the DA believes the current crime fighting strategy is failing our communities. We need urgent action, stronger intelligence, better resource police stations and devolved policing powers.
Now,
And in sports in soccer,
watch now,
Mamelodi Sundowns
watch now.
secured their second CAF Champions League title by playing
You can see how
to
I'm
a
going
1-0
off the station.
draw against the AS.
And as I'm going off the station, the sound becomes, of course, you keep on sliding it till you get the loudest sound. Watch now again.
It's a 2-1 aggregate win after they defeated the Moroccan side 1-0 in the first leg in Pretoria last weekend. By winning, Sundowns have secured a place in the FIFA Intercontinental Cup and the FIFA Club World Cup. Captain Rowan Williams says they deserve this.
Let me
What this
connect
team
the
has been
tape.
through, not only this season, the last 4, 5, 6 years.
Now
knocking
I
on
got the
door
filter.
every season.
Now I got the filter connected and listen to it. It sounds a bit more pleasant.
Stop, finally the door open for us. We deserve it, fully, rightfully so. To the Mutsipe family, the technical team, the Masandawana, the entire South Africa, thank you for the support.
Now I disconnected basically the capacitor. Okay.
For
And
our
listen to-
financial indicators, the dollar trades at 16 rand 31 cents, the euro at 19 rand, and 1 British pound cost 22 rand 1 cent. A Bitcoin trades at $77,566. Gold sells at $4,571.
Okay, capacitor engaged.
Cents a fine ounce, and
No
Brent
capacitor.
crude oil is quoted at $94.67.
So basically, what I have done is I demonstrated a small little wireless detector that we actually make and supply, and anybody can make it, provided it takes a lot of experimentation getting the oscillator coil sort of tuned properly. Of course, what one can do, sorry, I had to go quickly fetch the capacitor. Let me just fetch it from a plastic bag. Okay, of course, one can use something like this. Okay, if you have got, instead of this capacitor here, you can actually connect a capacitor, something like this, and then you can actually tune. And it will give you a much greater sort of, and more stations that you're capable of catching. One thing I got to mention about the AM medium wave sort of any receivers, even if it's as I said top-notch AM receiver, the signal will keep on fading. Depends on the propagation, which is dependent on the temperature, barometric pressure, whether it's a winter, summer, and so on. So basically, this is why basically we have moved, the society has moved predominantly from AM medium wave sort of radios to the actual FM band, because in FM band you can get a much more stable and predictable sort of signals at the same level at any sort of weather conditions or any time of the day or night. Where with AM, sometimes the conditions, propagation conditions are not that good, and it will keep on fading. It will come and then it will go, and then it will be louder, softer. It will be a lot of static interference, from the weather and things like that, and then it's crystal clear. One more time, and on that note, I'm going to end the video, and thank you for watching.
Pulpit.co.za. For burners during office hours, 012-334-1200. Radio Pulpit, your daily companion.
Okay, thank you for watching.